For our group project, we will be talking about the physics behind glasses. My name is Zoe Rosicki.
I'm Kimmy Abashi.
I'm Jacqueline Okulam.
And I'm Maxine Galicia. Throughout the semester, we learned about many interesting different topics, but the one that stood out to my group and I the most was convex and concave lens. Since we all wear contacts and glasses too, we thought it was fitting to explore the physics behind glasses and how they help correct our vision.
To briefly go over, the left image above shows a convex lens which causes light to converge. This means that the light refracts inwards towards a focal point, while the right image depicts a concave lens that causes light to diverge, meaning the light spreads outwards. The way each lens differs from one another helps correct near or farsightedness, all of which will be explained shortly.
To start from the beginning, and in simple terms, light enters the eye through the cornea, which bends light to help the eye focus. The cornea is shown in the image above as the dome-shaped surface that covers the front of the eye. As the light passes through the pupil, the iris, which is the colored part of the eye, controls the amount of light that passes through. From there, light passes through the lens of your eye, which is a clear inner part of the eye, and works with the cornea to focus light onto the retina. The retina is a light-sensitive nerve layer which lines the back of the eye. From this point, the image is transmitted through the optic nerve and into the visual cortex of the brain.
Unlike the previous slide, sometimes people's lens may be too curved or too large, and light does not focus on the retina properly. Nearsightedness, also known as myopia, means people can see objects clearly close up, but far away objects are blurry. In contrast, farsightedness, also known as hyperopia, means people can see objects far away clearly, but objects close up are blurry. In the following slides, we will go into detail about how concave and convex lens can correct these visual impairments.
Concave lenses are used in glasses that correct nearsightedness, which is also known as myopia. Because the distance between the eye's lens and the retina is longer than it should be, nearsighted people are unable to make out distant objects clearly. Nearsightedness will result if the light from a distant object is refracted more than is necessary, and is usually the result of a bulging cornea or an elongated eyeball. This causes light to be refracted more than usual, and the image forms in front of the retina. In order to fix this, light needs to be refracted less. Placing a concave lens in front of a nearsighted eye reduces the refraction of light and lengthens the focal length so that the image is formed on the retina rather than in front of it.
To reiterate, hyperopia or farsightedness means that people can see objects that are far away clearly, but objects that are close are blurry. This is because the light is focused beyond the retina, or the focal point is beyond the retina. Farsightedness can be fixed with a convex-shaped lens. What differentiates a convex lens from a concave lens is that the edges in a convex lens are further apart than the edges of a concave lens. When a convex lens is placed in front of a far-sighted eye, the focal point is corrected and moves to be located right on the retina. Once the focal point is corrected with the convex lens, objects far away, as well as objects close by, can be seen clearly. So that was our presentation on the physics of glasses. Thank you for listening.